In 1589, the mathematician and scientist Galileo conducted an experiment to answer a question much like the one in item 1. Galileo dropped balls from the top of the Leaning Tower of Pisa in Italy and determined the time it took them to reach the ground. Galileo used several balls identical in shape but differing in mass. Because the balls all reached the ground in the same amount of time, he developed the theory that all objects fall at the same rate. Galileo's findings can be represented with the equation h of t equals 1,600 minus 16t to the second power, where h of t represents the height in feet of an object t seconds after it has been dropped from a height of 1,600 feet. Number 2, make a table of values for Galileo's function h of t equals 1,600 minus 16t squared. So we want to plug in if my t is 0. Then we want to plug in t is 1, 2, and so on. So we're going to do 1,600 minus 16 times 1 to the second power. Oops. There we go. I got 1,584. Gonna take this answer. Sorry. Look at what I did. I plugged in 1, but I wrote it here. So I need to actually remove this. This 1,584 should go down a line. 1,584 should be here. Okay, let's see if what it was. Oh, at 0 it was 1,600. 0 means I haven't dropped the ball yet. Okay, let's change that to 2. I got 1,536. Change it to 3. I got 1,456. At 4 seconds, it's going to be at 1,344. 5 seconds after it's been dropped, we're going to have it at a height of 1,200. 6 seconds after the ball has been dropped, it is at 1,024. 7 seconds after I drop that ball, it's going to be at a height of 816 feet. We're now going to do at 8 seconds after the ball has been dropped. It is 576 feet above the ground. At 9 seconds, it's going to be 304 feet above the ground. Let's check this out. At 10 seconds, it's at 0 feet above the ground. I'm going to flip over to the next page to move to question 3. I'll be referencing this a lot, so don't put this page, make sure it's close by. Number 3, construct viable arguments. Why would negative domain values not be appropriate in the context of this problem? What does the domain stand for? The domain, my x or my t in this case, is number of seconds. Number of seconds since what? Since we dropped the ball, right? Would it make sense to look at negative seconds? No. T is representative of the domain, which is time in seconds since the ball is dropped. Negative time does not make sense in this context. Using your table of values, graph Galileo's function. All right. Well, we know we start at, it looks like these are going up by 100. So 0 was at 1600, right? At 1 second, each one of these little lines represents 1. It is 1584, so that's kind of close to 1600, but not quite there. At 2 seconds, it's a little closer to 1500. At 3 seconds, it's at 1456, so that's about halfway between 14 and 15. Then we have 1344, which is again about halfway. We have at 5 seconds, it's at 1200. So it's right about here. We got 1024. Close to about the 1000 mark. Yeah, 1000, but not quite there. We're almost at 8. About 3/4 of the way up. Then we're almost at 300, but a little bit above. And then here we're on the mark. So we have this that is clearly not a straight line. It's more of an arc-ish. So I kind of did it to the best of my ability. It's kind of got this curved action going here. It says, what is a reasonable domain of this function represented in your graph? Well, what happens at 10 seconds? At 10 seconds, we have a height of 0. Now, let me ask you. If we went to 11, my guess is this graph is going to continue to keep this pattern up, right? And it's going to go down here. But remember, this is basically my ground. When it hits here, it's hit the ground. Does it make sense for it to keep going past when it is at 0 feet above the ground? No. So my domain goes all the way from 0 to 10, both included. Okay. At 0 seconds, we're at the top. At 10 seconds, the ball has just hit the ground. Okay, what's a reasonable range? Now, range represents the height of the ball. What's the highest that the ball will ever reach? 1600. What's the lowest that the ball will ever reach? 0 when it hits the ground. So here we're going to have 0 is less than h of t. which is less than 1,600. Okay. What is the y-intercept? Now, y-intercept is where does it cross the y-axis? Well, it meets the y-axis right here. That is my y-intercept. So that ordered pair there is 0, 1,600. What does that y-intercept represent? At 0 seconds, the ball is at a height of 1,600 feet. What is the x-intercept and what does it represent? Well, x-intercept would be where the graph crosses the x-axis, and that ordered pair is 10, 0. This basically tells us that at 10 seconds, the ball is 0 feet above the ground. Or you can even say it's hit the ground now. Identify any extrema of the function shown in the graph, and what do these extrema represent? Extrema, remember, is max or min if it's on a closed plane. Well, we have a maximum. That maximum is 1,600 feet. That is the greatest height. Of the ball. And that was at 0 seconds. What about min? The lowest value is 0 feet, which is the lowest height of the ball at 10 seconds. All right. Take a moment to answer 2 through 9 and to get that copied over. Answer the debriefing question on the slide to follow.